In this session, we will be analyzing the filter characteristics, specifically a FIR filter, using a tool. So, FIR tool can be used using MATLAB. The command window, we have to write FDA tool, and the filter design this window will get open, as mentioned in the previous video. So now we will be analyzing various parameters are given here, and we are looking for the characteristic of FIR filter, as FIR is very famous to provide the linear phase characteristic. So we will be analyzing the magnitude response as well as the phase response of the filter. So as all of us we can see, the response of the filter can be analyzed using various parameters. So in the previous video, we have seen the IAR filter using magnitude response. But FIR is very famous for the phase response. So we will be analyzing the phase response, magnitude response, and the combination of both using FIR filter. So FIR filter is designed using various methods. So we will be preferring here to check with the windowing technique. There are various windows which are used for the design of FIR filter. We selecting here from this particular menu which type of window we are going to check. So very first I am going to start with the basic window, that is a rectangular window. So I will be selecting rectangular window, and then the filter order will be checking right now with the minimum order, that is 5 or 6, that easily we can see the coefficient of the filter also. The stop band frequency is 48,000 mentioned here in hertz, and the cutoff frequency or pass band frequency here is 10,800. It is a low pass filter, and then attenuation in the pass band they have already fixed according to this FTO tool properties, that is 6 dB. So we'll just design this filter. So we have designed this filter. This type of characteristic is coming. All of you can see here, the characteristic is between the frequency that is on the x-axis and the gain that is on the y-axis. So we will be analyzing now, it is a magnitude response basically. So we'll be looking for the phase response, whether it is linear or not. So we'll be clicking here, we'll be going to analysis, and we'll be clicking over the phase response. So we can see here, the filter response is here, the phase characteristic of filter response is linear. And then if we combine together the phase and magnitude both together, so we can find out as soon as in the windowing technique, while designing the filter, we will be having main loop and side loops. So with respect to first main loop, the characteristic is linear from 0 to 15. And again, this will keep repeating. For the other side band, magnitude response, in that lot of distortions are there. So that is the reason rectangular window is very first kind of the basic window. To avoid this side loops, we will be having various other type of window. So we'll be looking for the other window, and among that other window, we are having and Hamming window. We will be selecting for the Hamming window, and we'll be analyzing the filter characteristic with the same set of parameters. As the parameter is again, we kept filter order 5, and then stop band and pass band frequency as it is, keeping pass band attenuation of 6 dB. So now we'll design this filter, checking for the magnitude and phase response. So this is magnitude response of the magnitude and phase response of the Hamming window. We'll be analyzing this phase response separately and magnitude response separately. So we can see here the main loop is covered. The width of the main loop is more, and the side loops are quite less, what we have seen in the rectangular window. Again, we will see the joint analysis of magnitude response and phase response. In the previous case, apart from the main loop, side loop was also there. But side loop width can be minimized based on the various type of windows what all we are selecting. So we can look for a window which is very popular, that is a Kaiser window. And we'll be analyzing the behavior of Kaiser window for the design of FIR filter, and we'll see in which way this is different than the previous two windows. So again, we can see the linearity and then the side loops. The side loops are still more, so we can see how it can be minimized further. other parameters what all we are considering. So we can change the parameter and we can analyze and we can fix which particular at which particular frequency we are looking for the linearity property of FIR. Here we can analyze. We can see the pole zero characteristic of FIR filter, and we can see the numerator and denominator coefficients of FIR filter. This is the pole zero characteristic in which we can see the representation of FIR filter. So, for this session.